In this video, we're going to learn how to find the middle of a linked list. So in this video, we're going to see two methods to find the middle of a linked list. The first method will going to be our very obvious method where we're going to count the nodes. So we can say it as like count method. Second method we're going to use some pointers like slow and fast pointers to find the middle. So this one method is extremely important, this slow and fast pointers. So firstly, we see this, what is this count method and how to use this. So let's say you have a linked list given as 2, 3, 4, 5, and 6, and it points to null. So we can see here that this is a list where it have odd number of nodes. So we can count here that 1, 2, 3, 4, 5. So we have 5 nodes. So what's gonna be the middle of this linked list? So we can see that 3 is going to be the middle of this linked list. But if you divide, so if you take here that count is equals to 5, and if you want to find the middle, you simply gonna divide this by 2. You will gonna get 2 as your answer. Okay, but we don't want 2. We want 3 as to be our answer, right? So we're just gonna add 1 into here into our count, and we can just simply use this here in our middle to get the 3. So we will be getting a 3 here, and that's what we wanted. So we got our 3 as our middle. So anytime you get a list where there's our odd number of nodes, you can just simply add 1. You can just simply add 1 there, and after that just divide it by 2, you will be simply getting your middle. In the second case, let's say you have one more node here. So like there are even number of nodes. SS7 also is here, that it points to null. In this particular case, our middle is going to be our 4. Okay, so this is going to be our 6th node, so we can mark it as 6. So we need this as to be our middle, because like see, in a even number of nodes there can be 2 middles. Firstly, this one can be also middle, but this one can be also middle, but we're going to consider our second middle as our main middle. Okay, so we want 4 as to be our middle. So we see here our count is 6 and we want our middle to be 4, so we're going to divide 6 by 2, which is going to be 3, and we're going to add 1 later. After that we're going to get the answer of the middle, so that will be giving us 4. That's how we have to do. So in the case of, so we can write here that in the case of odd, when you have odd number of nodes, you need to increase the count by 1. So whatever you get the count, just increase that by 1 and then divide that by 2. You will be getting your middle. In the second case, when you have even number of nodes, you just simply need to take the count, divide it by 2, and then increase by 1. So you will be getting your middle as like this, like adding 1 after you divide this count divided by 2. So let's see how does this code looks like. Okay, so if you're going to write the code for this, you need to declare a variable that is going to be count. So int, let's say count, and we're going to initialize this as 0. Then we take our another variable which is going to be our middle variable, and we can leave it as it is. Now we're going to declare a pointer which is going to traverse the list to count the number of nodes in the whole list. To do that, we're going to do list node star, let's call that as a temp, and this temp is actually will be pointing to the head of the list. Okay, so we have this list, so we're going to declare this is our head, and our temp pointer also will be pointing to this head. So our temp pointer also will be pointing to our head. This is our temp pointer. So to find how many nodes are there in the whole list, we're going to traverse this temp until it becomes null. Okay, so firstly our count is 0, and the temp is here. So when we're going to move the temp from this place to this place, we're going to increase our count. So now our count is 0. Now if our temp comes to this place, our count will be 1. So we can mark this as 1. Count is 1. Now our temp will gonna move again from this place to this place, and our count will gonna become 2. Now our temp will gonna move here, our count will gonna become 3. Then again our count will gonna move forward here, and our count will also gonna increase. It's going to be 4. Then the temp will gonna increase again to here, and our count will gonna increase again, which is going to be 5 now. And now our temp will gonna move ahead, and it became null. So we can just simply make it null. So our temp is pointing to null, and as soon as it points to null, we're gonna increase our count again just once more, which is 6 now, and we can just end the loop. So that's what we're gonna write here in our loop. So we're gonna take our while loop now, in which inside of this we're gonna write temp is not equals to null. So we have to run this while loop until the temp becomes null, and after that we're gonna write inside that this count plus plus count is increasing and the temp is moving forward. Okay, so the count is 0. As soon as it enters the loop for the first time, the count increases to 1, and as soon as the count increases to 1 here, like the count became 1, and the temp also comes here. Temp, this is the temp's next, this is the temp's next, and this one is temp, right? So we are making temp equals to temp's next, so it will gonna move the temp here. So temp will going to be here, and count will going to be 1. Okay, then we're gonna enter the loop again. The count will gonna become 2, then the temp will gonna become again, it's gonna move forward. So we can end this loop. So we just so we can just close this loop. So we can close this loop now. So when it will gonna come out of the loop, the temp will be null. Okay, that means we had already that means we had counted how many nodes are there in our linked list. We're gonna make our temp go to head again. Okay, so you can see here that our temp is here. So when I did temp equals to head, our head straight points to head again. So this was our head initially, and now this temp here gonna point, it will gonna point straight here again. So our temp is this. Okay, so temp is equals to head. So now we need to check for odd and even. So let's say if the count percentile 2 is not equals to 0, that means it's odd. So just assume that our count is equals to 5. Okay, when you're gonna percentile this 5 to 2, you will be getting the remainder. So the remainder of this will going to be 1, and the 1 is not equals to 0. That means that anytime it will gonna be an odd number, the count will going to be odd, it will be leaving remainder as 1 every time. And 1 is not equals to 0, so this will going to be true. So this condition will gonna become true. That means count is actually odd, and that's what we want. Okay, this will gonna show that count is odd. Now if we find out this thing that it is odd, we just have to go with this condition that we wrote here. If it is odd, you have to find the middle by count plus 1 divided by 2. So we already have our middle variable. Middle is going to be equals to count plus 1 and then divided by 2. It will be giving you the third node. Like if there are 5 nodes and if you want to find the middle, and the middle will going to be the 3. So when you're gonna, our count is 5, so this is 5 and plus 1 is going to be 6 and then divided by 2 will be 3. That's how you will be getting your middle as 3. Okay, so this is the case for the odd. Now what if it's even? Now in the else block, else if the count percentile equals to 0, then you need to find the middle. Firstly count divided by 2 and plus 1. As we had discussed here, that it for the even nodes you need to find the middle by using this count by 2 plus 1, because we needed to take our second middle. Okay, we need to take our second middle, not the first middle. It will be giving you the second middle when you're gonna add 1. So these are the both conditions for even and odd. In the end, you need to traverse again. Now this middle value will going to be the value of the middle, but you need to return the actual node of the middle, not the value middle. Okay, so to do that, we're gonna traverse, we're gonna use the while loop again. So while middle is not equals to 1, we're gonna start this loop. But why middle not equals to 1? So let's say our count is 5 and you will be getting your middle. So you will be getting your middle in the case of 5, you will be getting your middle as 3. Okay, so you will be getting your middle as 3. So let's take this our example, and we're going to remove the last node as we want 5 nodes to be there. Right. Okay, so if our middle is this, okay, this is our middle, and our middle value is 3. So we need to stop at this position. So we started this temp again from the head, and we need to stop this temp over on the middle. How are we going to do that? So you're going to write here in this, you're going to decrease the middle, negative, negative, and you will going to increase the temp. So you're going to move the temp ahead. Why we did this? So let's see here why we did this. So this is our middle, and we need to make this temp move here. Okay, our temp is at head position. So firstly we're going to decrease our middle. So our middle is 3, it will going to become 2, and as soon as it becomes 2, as soon as the middle becomes 2, our temp will going to move ahead. So temp will going to move here on this temp, right? Now we're going to move ahead. So like in the second iteration, what's going to happen is that this will going to become 1 because we're decreasing the middle value, and this temp will going to move ahead. Temp will going to come here. So now we can see then when the middle is 1, our temp is actually on the middle node. This 4 node was our middle node. So when we're gonna find out that the middle has become 1, we can simply say that temp will pointing to that node, that middle node. That's what we wrote here. Middle minus minus, it's decreasing, and we are moving the temp, and we have to do this until the middle becomes 1. As soon as the middle becomes 1, as soon as this middle becomes 1, we can just end the loop, and our temp will be going to be at that particular node. Okay, so in the end, you can simply return this temp because this is going to be our middle node. So let's see on LeetCode. let's write this code and let's see if it works or not. So this is our equation. I'm gonna use our count approach here. So at first what we were doing, that we were initializing count to 0. We were taking a middle variable, and then we were taking a temp pointer, which will be pointing to head. This will be helping us to find our middle node. Now we were starting our loop, and the loop is going until the temp becomes null. As soon as the temp becomes null, we're going to come out of the loop. So in this loop, what we'll be doing is that we are increasing the count and we are moving our temp ahead. Okay. When we're going to come out of the loop, our count will be counting all the nodes. The count had already counted all the nodes. Now we're going to check if the count is odd or even. So to check that, we're going to use this percentile2 is not equals to 0. If it is not equals to 0, that means it's odd, and in the case of odd, our middle is going to be count plus 1 divided by 2. Okay. And after that, in the else if condition, if you finds out that our count percentile2 is equals to 0, then our middle is going to be count plus 1. So this will gonna help us finding the middle for both even and odd. As soon as we find out this thing, we're gonna move our temp to point at head again. And then we're gonna start our while loop again until this middle is not equals to 1. When the middle is going to be 1, that node will actually going to be our middle node. So firstly, we're gonna decrease our middle as soon as we enter the loop, and then we're gonna increase our temp. Okay. When we're going to come outside of the loop, the temp will going to be our middle node, and we can simply return our temp. So let's see if it works or not. See, our code is accepted. In this case, our middle node was 3, so it returned 3 for 5. In this case, our middle was 4. We need to take our second middle. Like it's written here that if there are 2 middle nodes, return the second middle. Like in this case, there are 6 nodes and there are 2 middle nodes, 3 and 4, and we need to take the 4th node, and that's why we did plus 1 here to increase it just 1 more. Okay, so let's submit. So before submitting, we need to check for the edge cases. For example, it is possible that our head is null, or it is possible that our head's next is null. In both of these cases, like if there's only just one head, that is going to be our middle. So we can just simply return our head, and if the head doesn't exist, then we can also return our head, which is null. Now we're gonna submit this. So we can see our code is accepted. Okay, so let's see our second approach, our slow and fast punter approach. So before going to this approach, we need to understand something here. So let's say you have this path, and this path is 10 kilometers wide. Okay, and there are 2 persons, person A, person B. Okay, this A starts running, and this A starts to go and reaches this end point. Okay, as soon as the A reaches this end point, like see, so you have this person A and person B. Okay, this person A and person B starts running together. Okay, this A is running at 2 into speed of this B. Okay, as soon as this A reaches this end point here, we're gonna stop the B also. So let's say that A is running at the speed of so let's say A is running at the speed of 20 km per hour, and B is running at the speed of 10 km per hour. So we can see that A is running double the speed of the B. Okay. Now A starts running and A reaches here, the end point. Okay. And the B also was starting at the same point at this A started. Now if you calculate that how much time does A took to reach here, you're gonna see that we know this thing that speed is equals to distance upon time. So if we need to calculate the time, it is going to be distance upon speed. Distance is 10 kilometers and our speed is 20 kilometers per hour. So we can see our time is half an hour. So in the half an hour, the A will gonna reach this end point. Okay. So now we need to calculate where the B is going to be, because I said this thing that A and B are starting together, and if A reaches this, as soon as the A reaches this point, we're gonna stop the B also. So B is obviously going to be somewhere here. We just need to find where B gonna be. So we know this thing that the time is half hour for B also, and the speed of B is 10 kilometer per hour, and we need to calculate how much distance this does B covered. So distance will going to be speed into time, and speed is 10 and time is half, so we will be getting 5 kilometers. So we can see this thing that distance is covered by B is 5 kilometers, and 5 is the half of 10. So we're gonna find our B exactly at the middle here. This is going to be the B position when A is going to be here. Okay. So the conclusion of all these things was that if you take 2 pointers and if you make one pointer move at the double the speed of another pointer, then you will gonna find that the slow pointer is actually stopping exactly at the middle of the linked list when the fast pointer reaches the end. Okay, so let's see this thing with the case of our linked list. So you have this linked list, let's say 2, 3, 4, 5, 6, and it points to null. So we're gonna take 2 pointers, slow pointer and fast pointer. So our fast pointer is moving double the speed. It means that it is surpassing 2 nodes at the same time, while the slow is only surpassing 1 node. So you can simply say this thing when you're gonna write this in code, that slow is equals to slow's next, and the fast is equals to fast next. So our slow is here at first and our fast is here at first. So our slow is moving only one time. So our slow is only moving once. So it move once, the slow is going to be here. And our fast is going next. So fast next is this, 3, then next is this. So our fast is going to be point to this. So we're gonna rub this and we're gonna point our fast here. Okay, now again, slow gonna move only one time here. The slow will gonna move. This is going to be slow. And now our fast will gonna take 2 steps. So 1 and 2. Okay, it is going to be our fast here. Now after this, we finds out this thing that our fasts no more can go ahead. Like if you see this thing that the fast next is null now. This is the fast here now, and the fast next is null. That means that fast cannot go 2 steps. It cannot even go 1 step. As soon as it's gonna go 1 step, it will gonna become null. And if fast became null in only in 1 step, then in the second step, null's next, if you do, you will gonna get a segmentation fault. So we don't need to go here. So what is going to be our condition? We need to do this until our fast is not null and fast next is not null. So we need to run this while loop until the fast is not null or fast next is not null. So this can be confusing, that why we took fast is not null and fast next. So you understood this thing, that let's take an example of this. So as soon as this fast came here, okay, this fast next is null, so it ended here. So fast came here at the end. Okay, now we're gonna check again. So it finds out this thing that fast next is actually equals to null. So this condition actually became false. If this one is false, and this one is true, our result will also going to be false. So this while loop will never gonna run again. Okay, so condition will gonna become false. And what if our, like, we can see here that our nodes here is 1 2 3 4 5, so we have odd number of nodes. What if we have even number of nodes? So let's take linked list again. So 2 3 4 5 6 and then 7 also. Okay, now we are assuming that our linked list have even number of nodes. Does this gonna work for that also? Let's check that out also. So our slow pointer is here and our fast pointer is also here. Our slow pointer takes 1 step and our fast pointer takes 2 steps. So we're gonna go through that. Our slow pointer will gonna move 1 step here and our fast pointer will gonna move 2 steps. So 1 here, then here. So this is going to be our fast. Then our slow will gonna move ahead 1 step and our fast will gonna move 2 steps ahead. So 2 step means next, 2. So 2 steps means next and then next. So our fast will going to be here. Done. Now as you can see here that our fast next is a node, which is good, but our fast next is not a node. So we can see here that our fast is here and our slow is here. Okay, and our fast can still move ahead because our fast next is valid and our fast next is also valid. Like fast is null, that's okay, but it shouldn't be null's next. It shouldn't be like that our fast is here, then fast null, fast next is null, and then we are doing again the next. So null's next can give error. Okay, but this one can move ahead. Okay, so this will gonna move ahead, it will gonna give null. So we're gonna point to null after moving 2 steps. So 2 steps means like 1 and then 2. So we're gonna point to null and our slow will also gonna move with the fast but only 1 step. So our slow is going to be here. Now what we notice here is our fast in the end became null. As soon as this happens, we need to stop going forward, because if we started going forward, it will gonna give us the nulls next, which gonna give error. So we cannot move ahead of this. Our list ends here. In this case, we had wrote this case. If the fast becomes null, we're gonna stop the loop. We only are running the loop when the fast is not null. Our fast became null when the case was even. We can see our nodes are even. So if you have even number of nodes in the linked list, your fast will gonna become null and you have to stop it. Okay, so now we can see this thing out of fast has become null. That means this becomes 0. So we're never gonna go and check this thing. Okay, if it has already become 0, we know this thing that in the AND operator, if even one input is like, if even one in the AND operator, even if that one input is 0, that means our output output is also going to be 0. That means the while loop will going to be the false, and it will never gonna run this. So you can say this thing that when the case will going to be the even case, this is going to be our condition, and the case will when it's going to be our odd case, this is going to be our condition. So we saw this thing that our fast was here and our fast next was null, so we stop the loop. We cannot move ahead. Okay, so this is going to be our code. This is all. So like this is all the code is, and this is the most easiest way to find the middle of a linked list. It's way better than that count one method that we saw. Okay, so let's see on LeetCode how does we gonna implement this correctly. Okay, so firstly, the first thing that we need to do is we need to declare our slow pointers, and both pointer at first is pointing to head. Then we're gonna declare our another pointer, which is going to be our fast pointer, and it's also pointing to the head, right? Then we're gonna start our while loop until the fast is not null when the case is even, and another time when our fast next is not null when the case is going to be odd. In any of the case, one of them becomes false, the while loop will not gonna execute further. So our slow pointer is moving only once ahead, and our fast pointer is moving 2 steps. And after that, you just simply need to return the slow, because this slow it will be actually be pointing to the middle of the node. We saw this here. If you haven't noticed that as soon as this fast next became null, we end the loop. We finds out this thing that our slow is actually pointing to the middle of the node. This is the middle. This 4 is our middle. In this case, in the case of even, our second middle we wanted, and this slow is actually pointing to the second middle when the fast became null. So in both the cases, we can see that the slow is actually pointing to the middle node. That's why we use that. So when you simply return slow, it can work. You can see it's accepted. So now we're going to write our edge case also, where the head is actually equals to null, or our heads next is equals to null. Then in both the cases, you can simply return the head, and you can submit this now. You can see this accepted, so hope you like it. Second method is more preferable. The slow and fast pointers are very important.